All right, today, welcome to section 10.6, where we deal with some angle and arc theorems, and these tend to be very convenient theorems for us. Makes us save a little bit of work. So the first theorem says, the congruent arcs theorem, if two inscribed or tangent chord, again, these are going to be lumped together because of the fact that they have the vertex on the circle, if those angles intercept the same or congruent arcs, then they must be congruent. So looking at our diagram, we have angle ABD and angle ACD. Both of those arcs cut off, or both of those angles cut off the same exact arc, which is arc AD. So again, angle ABD, B is on the circle itself, that's the inscribed angle. ACD is the same thing, it's an inscribed angle. They're cutting off the same arc. What that tells me then is that angle ABD is going to be congruent to angle ACD because they're cutting off the same arc. So as an example of how that we might use this in a problem, we're given that we have the measurement of angle F and the measurement of angle S. So what I'm going to do is just kind of highlight these angles out. I'm going to highlight angle F right here. And I'm going to do the same thing for angle S. And you'll notice where those two angles intersect the circle is this arc right here, arc RH. Angle F and angle S are intersecting the same arc, which means that they're going to be congruent to each other because half of this angle or half of this arc is equal to half of this arc. It's the same exact thing. So I'm going to take 5x minus 12 and set it equal to 3x plus 8. And then solve for x. So bring the 3x over, bring the 12 over, and I find out that x is equal to 10. Now once I have that 10, I can plug it back into either angle F or angle S. They're both the same because, again, they're congruent. So I think probably the easiest thing to do would be to plug it into angle S. So when I plug in 3 times 10 plus 8, I know that this angle is 38 degrees. Similarly, angle F is going to be the same thing. Now at this point, what I want to do is figure out, well, if I know that this angle is 38 degrees, then how do I find the arc? So the arc is cut off by an inscribed angle. So if I have the arc, I divide it by 2 to get the angle. If I have the angle, I double it to get the arc. So arc RH is going to be double 38, 76 degrees. Again, using the idea that the two angles had to be congruent because they cut off the same arc. Our second theorem deals with semicircles. And a semicircle we know is going to divide a circle into two equal parts, both 180 degrees. If I have a semicircle, and then the endpoints of that semicircle are going to create another angle. And that angle is going to be inscribed and cut off by the semicircle. And that's got to be a right angle. So looking at the diagram right here, we know that HM is the diameter. It goes through the center of the circle. The angle that's cut off, any angle that's in between there, if it's just one angle, is going to have to be 90 degrees because it's inscribed, which means it's on the circle itself, the vertex is. Our arc right here is 180 degrees. So angle E is an inscribed angle, and my arc is 180. No matter where I put E, it's still going to cut off this 180 degree arc. So the inscribed angle has to be half of that. 90 degrees. So no matter what, you have a semicircle, you have an inscribed angle that cuts off that semicircle, then that means it's got to be 90 degrees. Alright, so in circle O, HEM is a right angle because HM is the diameter. It also means that arc HM is a semicircle. So with that in mind, we're going to try this problem out. We've got the radius of circle O is 13, so I know from O to N is 13, and same from O to W. So that's actually 26 for segment NW. I know that this segment right here is 10, and I want to find out what KW is. I have two sides of a triangle. It's very likely that I'm dealing with a right triangle here, but just to verify, NW is a diameter, and we have points going from that diameter to an inscribed angle. So what that means is that the angle right here is inscribed on the semicircle. It must be 90 degrees. So angle K is 90 degrees. To find KW, I use Pythagorean theorem. 10 squared plus x squared equals 26, or you might recognize that as a triple, 10, 24, and 26. Again, K is a right angle because it cuts off a semicircle. And our last theorem deals with the tangent-tangent angle. And this is a very specific case, and the method that we had used before with a vertex outside with subtracting the two arcs doesn't work very well for tangent-tangent angles. And the reason is there's a much easier relationship. A tangent-tangent angle, so again, angle ARC in this case is the tangent-tangent angle, and the minor arc that it cuts off, so arc AC, have to add up to 180. Because AR and C are both tangent segments, the measure of the angle and the arc are both 180 degrees when we add them up. So in this problem here, we have that GPI, this angle right here, is 4x. GI, this minor arc, is 13x minus 24. And we want to know the relationship, the measure of GRI, the major arc. So because I've got a tangent-tangent angle and a minor arc, I know that these have to add up to 180. Combining like terms, I have 17x minus 24 equals 180. I'm going to bring 24 over to the other side. And then I want to find out what x is equal to. So if I take 204 divided by 17, that's going to give me 12. And then from there, I'm going to plug that 12 back in. Now, I want to be careful on this one because I don't want to get too crazy with plugging in. I think it's easy to plug in the 4x, so I know that that's going to be 48 degrees. I think it's more challenging to do 13 times 12 minus 24, especially without a calculator. Now, I know the relationship between angle P, or GPI, is supplementary to arc GI. So if I take 48 away from 180, I end up getting 132. Now from there, I can take that 132 degree arc, the minor arc, and use that to find the major arc, which will be 360 minus that. So 360 minus 132 is going to give me 228 degrees. And that's my major arc. Now it makes sense because, again, major arc is going to be greater than the minor arc. It's going to be greater than 180 degrees. So again, those are our three theorems, and we'll be using those more